For this question, in part A, we're given this probability density function, and then in part A, we need to find what the value of capital A should be. And in order to find this value, we invoke this relationship. So we know that since this function is a probability density function, we know that if we integrate it, this should be equal to 1. So using this relationship, we can integrate this expression directly, and then using the fact that this integral should be equal to 1, we can deduce what capital A should be. So we're going to start off by integrating this expression. So we will integrate this expression to deduce what the value of capital A should be. And capital A should be a value such that this entire integral is equal to 1. And so now the challenge is to evaluate this integral. And in order to evaluate this integral, I'm going to invoke this result. So I'm not going to prove how you can derive this result. You can derive it using a double integral. I'm not going to show you how to do it in this video. I'll just use this result directly. So if you're evaluating this integral, e to the power of negative some constant times x squared, then the result is equal to square root of pi divided by the value of this constant. So in this case, it's just k. So we're going to be using this result for this question. So you can see that these two expressions are pretty similar, but there is a difference because here you have x squared, but here we have x minus a squared. But it turns out this difference doesn't really matter because we can always do substitution. So we can substitute u to be equal to x minus a. And then you can see that for this case, du is just equal to dx. And then doing this substitution, you can see that the integral, so 1 is equal to this integral. And then after you apply the substitution, you can see that the bounds don't change. For the lower bound, you start off with negative infinity. And you can see that when x is negative infinity, u is also negative infinity, so we have negative infinity. And for the upper bound, you have positive infinity, and you can see that this also doesn't change. So you go from negative to positive infinity. And then for the expression inside the integral, I'll just pull out the capital A, and then you have this e expression. So you have e to the power of negative lambda, and then instead of x minus a squared, we have u squared, because u is equal to x minus a. So we have u squared. And then we have du, because we've just shown that du is equal to dx. So in the end, we have an integral that looks something like this. And then now we can directly apply this result. So we know that an integral of this form is just equal to square root of pi divided by the value of this constant. So in this case, this is just square root of pi divided by lambda. So divided by lambda. And we know that this expression must be equal to 1. And so this implies a is equal to square root of lambda divided by pi. And so this is the answer for part A.